let's touch on this before the break. Critical value in relation to confidence interval. It was already sort of stated to you. And if you look into the relations and the formulas, it's almost there's almost nothing to prove or say, but let's do it anyway to be very explicit about this very close analogy between doing the hypothesis test and doing the confidence interval. To make that very specific, we talk about, within the hypothesis test framework still, we talk about what we could call the critical value. Now I've shown you that the critical probability is alpha. Let's talk about alpha 5%. That's in a way the critical probability. If a p-value becomes less than alpha, less than 5%, we reject, otherwise we don't reject. Now we could actually make the same reasoning and conclusion and statement directly on the scale of the observed t-test statistic, and in a way go backwards and say, what is the limit, what is the critical value of the test statistic that exactly makes the p-value less than 5%, making us reject, right? So we can look at this 5% limit and check what's the t-statistic really at this point. And that is exactly the critical values. These are the percentiles that we know very well from last week's, but now we call them critical values for the hypothesis test. Because these are exactly those values, such that if you observe a t-test statistic, which is the relative difference between data and hypothesis, if this observed discrepancy is extreme, more extreme than these 5% expectations of the t, called the critical values, then we reject. If you think, didn't he say all this once already? Well, then you're fine. To be very exact, I didn't say this exactly like this. I said we were going to find the p-value and then look whether the p-value was small. Now I'm saying let's just check directly on the statistic and see whether it's large or not. And then before I do that, I find the limits of what's large or not. And I use the alpha level to find those limits, and they are called critical values. And this is then how it would appear in the t-distribution, that we have the center of 0, we have the acceptance region in the middle, and we have the rejection region in the extremes. And maybe this is actually better to put it like this, that we have the observed x bar in the center, the sample mean, and then we have, and I guess you can recognize that. Basically, this plot is a visualization of the theorem that will come, and I think I've told you the result of the theorem a couple of times already, that you can see this is the confidence interval elements here, and the theorem states that critical value way of doing hypothesis testing, which is like a yes-no thing. Am I extreme? I reject. If I'm not extreme, I don't reject. That would be the procedure, right? This is exactly the confidence interval. That's basically what I'm now stating for the 5th time and putting into this theorem. And to be just a little more explicit, here I hope you can recognize this is the confidence interval formula that you were taught last week. It is the mean plus minus the t quantile times s over root n, the standard error of the mean, plus approximately plus minus 2 standard errors of the mean. Now, this theorem states that the confidence intervals are exactly those possible values of the mean that we accept by the hypothesis. And again, if you think, is that not just obvious? Then fine, yes, it's obvious. But maybe not the first time, maybe not until you were told it's obvious. That gives us a good way of interpreting the confidence interval. If we don't like this long-term risk interpretation that and if you definitely don't like the 70 dance thing, then forget about this and look at this interpretation here. The interpretation of the confidence interval is, in a way, repeating myself for the 6th time, it shows us the range of plausible values for the mean, the range of acceptable values for the mean. That's what the confidence interval tells us. For many ways, that's a good line of thinking. For me it is, and I hope for some of you also. And here's the proof. I don't think even but let me spend 30 seconds. It basically just says the obvious, that if I have a mu0 in the confidence interval, it's the same as the mu0 is closer to x bar than the definition of the confidence interval. And then I shuffle around one or twice, and I have the definition of the hypothesis test critical value approach. If I'm not extreme, I accept. So being in the confidence interval is equivalent to being not extreme, is equivalent to being acceptance, right? It's very simple steps here. But I spent a little time to make us think about this. Then a little one Kahoot before we break. Okay, you're there. Oh, you don't win now. You hit the wrong button? Bugger. Maybe you're lucky. We have an t-test statistic numerically larger than the critical values. It means we found something. It means we rejected the null. The t-statistic is more extreme than the critical, right? Large T means we found something. Okay? We break 15 minutes. I start 5 after again.